Okay, so graphing inequalities. If you're not sure what an inequality is, think of the word equality, which we know means equals, and the word in, or the prefix in, means not. So inequality means when something is not equal. So for example, if someone asks me, Ms. Flores, is your age equal to 20? And I say no, then the only other options are I'm either older than 20, greater than 20, or my age is less than 20. So this is what we're talking about. You've probably seen this before. These symbols are called inequality symbols. We use them when something is not equal. And this one means greater than. The next one is greater than or equal to. Now, the reason why it's greater than or equal to is because technically it's like merging an inequality sign and an equal sign together. So it's like you're morphing them together into this symbol. So we have the less than, and a less than and an inequality, and a less than and a equal sign morphed together gives you the less than or equal to symbol. So it's like two symbols in one. So these are very important. You have to remember which is which. Can't confuse them because you're not going to see these labels. You're just going to see the symbol. And for some of us who might make that mistake and interpret them differently, I want to just a little side note or a little hint. A little trick that I like to say is if it looks like this, that kind of looks like a crooked L, and I can write the word less than. So if the symbol looks like you can make it into an L and complete the word less than, it's the less than symbol. And the other ones, it kind of looks like an italicized L maybe sometimes. And the other one is obviously the greater than symbol if it doesn't resemble an L. So there you go. Let's look at the first example. When we're talking about inequalities, we are trying to determine values that make these inequalities true, right? You want to think of numbers that really are greater than something or numbers that are really smaller than something. So let's look at this example, and they're going to be asking us to check if an inequality is valid or true. So, is -2 a solution to the following inequalities? And we have two of them to check, A and B. First one will be y minus 5 is greater than or equal to 6. So is true a solution? What that means is -2 a valid value for y that will hold this inequality to be true? So let's check. What I like to do is what I like to call plug-in bubbles. And anytime I'm going to plug in, whether it be inequalities or an equation later, I always draw a set of parentheses. Common practice so you just don't confuse negatives anywhere else. And then what you do is you plug in the value that you're going to be checking into this bubble that replaces the y. And then we do the math. -2 and a -5 or -2 minus 5 combined gives you -7. And now you ask yourself, is it true that -7 is greater than 6? So for reference, 6 is over here, -7 is over here. So it's not true, right? -7 is not greater than or equal to 6, so the answer to this one is no. -2 is not a solution to this inequality. Again, just plug it in, check it, and verify that it's true. The next one, -5.5y less than 14. And again, you want us to check -2. It might be another number, but for this one, it's -2. So what I'm going to do again is a plug-in bubble for the y. And my -5.5 is still here. And now in that bubble, I'm going to plug in the value they want me to check, which is -2. And negative times a negative I know is a positive, and 5.5 twice, or times 2, gives me 11. And now the question is it true that 11 is less than 14? And again, for reference, we have 11 first, then 14 over here. So the answer is yes. This one is smaller than 14. So we're going to say yes. Negative 2 is a solution to this inequality. The first one, it wasn't. Next example. Now, graphing inequalities, right? We know negative 2 is a solution, but you also need to know that inequalities don't just have one number that make things true. For example, if I tell you, I'm not 20 years old, I'd say I'm older than 20. Your mind starts thinking of all the possible numbers it could be, right? It's not just one specific answer. There's many numbers greater than 20. So this is how we're going to interpret them. Example 2. As long as you say something is greater than, you give yourself a big bank of numbers to choose from that it can possibly be. So we're going to graph this. Y is greater than negative 8. What this means is they want you to put on a number line all of the Y values that will work, that are greater than negative 8. So you can start thinking to yourself, think of this as filling in the blank. So I want you to fill in the blank. Blank is greater than negative 8. You're picking a Y value. Blank is greater than negative 8. Think of a number. That completes my sentence. Blank is greater than negative 8. And I'm going to go with an obvious one, positive 8. I know that positive 8 is greater than negative 8. As long as you chose a number that's valid, you did the right thing. So here's 0. I'll say here's negative 8. And the one I chose is over here. You could have chosen maybe 6. You could have chosen 1. You could have chosen 4. You could have chosen negative 7. You could have chosen negative 1. All of these values are bigger or greater than negative 8. Which means if we ask the whole world, where are your numbers at? They're going to be anywhere in here. So all of the numbers you could have said or thought about that would have been correct are any of them in this region. And that's how we graph it. Now the final thing we need to think about is what happens at negative 8? Is negative 8 greater than negative 8? No, it's not, right? It's equal. So because we can't say that negative 8 is greater than negative 8, we don't want y to be negative 8. We don't want negative 8 to be shaded in. So because we don't want it shaded in, we do what's called an open circle. And that just lets you know that we're not going to include negative 8, but everything after it is valid. Now, a lot of students get confused, so I just want to do a little note here. When you see this, just straight out, less than and greater than, that is going to be a open circle. And if you see something like less than or equal to, greater than or equal to, that's going to be closed circle. Okay? Now, we work really fast. You might get confused. When do I close it? When do I shade it in? And me and my stories makes it a little easier. So here's the deal. I'm going to call these little lines little doors. Okay? These are doors. These don't have little lines, so these do not have doors. And I want you to imagine that you take the hinges off a door in your, say your bedroom door. Your parents remove the entire door and toss it in the backyard. You can no longer close your door. Your door is missing. It's gone. There will be a big hole in your wall and you can't close it. So there you go. You have a door, close it. If your door is absolutely gone, it's missing, you're going to have a big hole. It's going to stay open. So remember my door story, and then you'll know immediately whether to shade it in or leave it open. Of course, with the deeper mathematical understanding that this means including the number, you're shading it in. The equal sign is missing. You don't want to include the number, so you don't shade it in. All right, let's look at example 3. we're going to graph -1/2 less than or equal to x. And again, they want us to shade in all the region where we have valid x numbers or values for this inequality. So again, every single time you want to determine which side you're going to shade, you must pick a number. You can never go wrong. So let's fill in the blank this time. -1/2 is less than or equal to what? Fill in the blank. -1/2 is less than or equal to, I'm going to just say +1/2. So as a reference, here's 0, here's -1/2, and mine is over here. I chose +1/2. You could have chosen 0, you could have chosen whole big numbers over here, you could have chosen -1/4 over here. Any of these values are all the points you could have thought about, you could have said, classmates could have thought about, that would make this true. So what we do is we shade them all in, telling you that any number in this region would have been true in this equation or inequality. So now, is it true that -1/2 is less than all of these? Yes, it is. But again, what happens at -1/2? Can we say that -1/2 is less than or equal to -1/2? Yes, we can. We can say it's equal. We do want to include the -1/2. And to include it, we shade it in. And again, remember, you got the door, close it, solid. All right, and one last example. And please don't just look at the inequality and say, oh, it's less than, all to the left. Oh, it's greater than, shading to the right. That is not valid way of thinking because it depends on which side your variable's on. So don't make that mistake. Graphing 4 is greater than or equal to y. And again, where are all those values for y that make this inequality true? 4 is greater than or equal to what? Fill in the blank. 4 is greater than or equal to blank. And I'm going to say 4 is greater than 0. 4 is greater than 0, so I can use this one. Oops. You could have said 4 is greater than 1. I'm sorry, 1, greater than 3, greater than 2, greater than all these negative numbers. So any number over here in this whole region would have been valid. Now, sometimes they'll do like a line on top, and I'll show you later what that looks like. So hopefully the number you were thinking of is in this region somewhere, and that just tells you that you pick the left side, shade everything else on the left. If your number ends up on the right side, you shade everything else on the right. So now this has my door, and I could say that 4 is greater than or equal to 4. It's equal. So I do want to include it by shading it solid. Okay. So now, when you see questions like this on a different place, in a book, in a workbook, sometimes they don't do it like this. They'll have the bar, and then they'll, instead of shading it on the bar, they'll do it like this on the top. So that still means the same thing. You can see them telling you from 4 to the left with an additional bar above it, or they can shade it in on the bar. So here's an overall, right? So let's recap. Say you have an inequality, and wherever your number is that you chose to fill in the blank, it's on this side, and that means that's the side you shade. If the questions ask you to think of a number, let's say this time it's 1, and you've picked a valid number that you think is true, and you happen to pick it on this side, then you shade everything else on that side. So you're really just thinking of one number so that you know what side to shade. If your number landed on the right, shade everything else on the right. If your number landed on the left, shade everything else to the left. And therefore, you will cover all the other values that you could have mentioned. So that's how you graph inequalities, and I hope it made it simple and easy to understand.